students! Welcome back to another fun and adventure in the world of science. I'm Teacher Jeanette, and I will be your science teacher. Our lesson for today is all about the percent composition of compounds. Our learning competency for this week is to determine the percent composition of a compound given its chemical formula and vice versa. We also have the following objectives for today's topic. Determine the percentage composition of each element in each compound. Compute the molar mass of a compound. Calculate the percentage composition given its chemical formula. Suppose you had your quarterly test and you got 40 out of 50, meaning you got 80% of the correct answer. The percentage can also be seen in the packages of grocery items such as canned goods, beverages, or even the snack. For example, this mixed snack consists of 24 grams of cornic, 18 grams of green peas, 30 grams of peanuts, and 23 grams of kernels. The sum of these ingredients is 95 grams. Now, let's calculate the percent composition of cornic, green peas, peanuts, and kernels in this mixed snack. To compute the percent composition, you need to divide the mass of cornic, green peas, peanuts, and kernels by their total mass. Now, we have 24 grams of cornic divided by 95 grams times 100 is equal to 25.26%. Next, we have 18 grams of green peas divided by 95 grams times 100 is equal to 18.95%. Then, we have 30 grams of peanuts divided by 95 grams times 100 is equal to 31.58%. Finally, we have 23 grams of kernels divided by 95 grams times 100 is equal to 24.21%. If we are going to add 25.26, 18.95, 31.58, and 24.21, the sum is 100%. But what is percentage composition? The percentage composition of a given compound is defined as the ratio of the amount of each element to the total amount of individual elements present in the compound multiplied by 100. Here, the quantity is measured in terms of grams of the elements present. Chemists are able to analyze an unknown substance by determining its percentage composition by mass. The result of this analysis can be compared with the shear composition of known compounds to see the probable identity of the unknown substance. Let's use this formula. The percent of an element is equal to the mass of the element divided by the total mass of a compound times 100. Let's have the sample problem. Glucose, having the molecular formula of C6H12O6, is the main type of sugar in the blood and is the major source of energy for the body's cells. Glucose comes from the food we eat, or the body can make it from other substances. Glucose is carried to the cells through the bloodstream. Several hormones, including insulin, control glucose levels in the blood. Now, let's compute the percent composition of glucose. Step 1. Find the molar mass. To get the molar mass, you need to identify first the elements in the compound. In this formula, we have carbon, hydrogen, and oxygen. Then, you need to get the mass of these elements, and we are going to use the periodic table for this. Based on the periodic table, the mass of carbon is 12.01 grams per mole, hydrogen is 1.01 grams per mole, and oxygen is 16 grams per mole. Going back to our solution, we have 12.01 grams per mole of carbon, 1.01 grams per mole of hydrogen, and 16 grams per mole of oxygen. Next, we need to multiply the mass of each element by its number of atoms. To get the number of atoms, we need to look at the subscript of each element. Remember, if there's no subscript written, the number of atoms is equal to 1. In this formula, carbon has 6 atoms, hydrogen has 12 atoms, and oxygen has 6. 12.01 times 6 equals 72.06. 1.01 times 12 equals 12.12. And 16 times 6 equals 96. Add 72.06, 12.12, and 96, and the sum is equal to 180.18 grams per mole. Step 2. Determine the percent composition of each element in the total compound. To compute the percent of an element, divide the mass of the element by the total mass of a compound times 100. Let's start with the mass percent of carbon. The mass percent of carbon is equal to 72.06 grams per mole divided by 180.18 grams per mole times 100. Cancel the common unit. The answer is 39.99%. Next, the mass percent of hydrogen is equal to 12.12 grams per mole divided by 180.18 grams per mole times 100. Cancel the common unit. The answer is 6.73%. Lastly, the mass percent of oxygen is equal to 96 grams per mole divided by 180.18 grams per mole times 100. Cancel the common unit. The answer is 53.28%. This is the mass percent of glucose using the pie graph. We have 39.99% of carbon, 6.73% of hydrogen, and 53.28% of oxygen. Remember, always make sure the sum of the mass percentages of all components adds up to 100%. If it doesn't, you need to go back and find your mistake. Now, it's your turn. Find the mass percent of the elements in water. H2O. You may pause this video while computing it and play it to check your answer. The correct answer is 11.11% of hydrogen and 88.89% of oxygen. We usually use the percent of composition to know the nutrition label of the food we eat, to measure the proper amount of chlorine in a pool, and to create money or new substances. I hope you enjoy our class today. Again, this is Teacher Jeanette. See you again in my next class. Goodbye.